And last but not least, we are here with number 7. A recent college graduate buys a new car by borrowing $18,000 at 8.4% compounded monthly for 5 years. What is the monthly payment? What is the total payoff? How much in interest? Those are always the questions we're going to ask ourselves. And if she were to pay an additional $100 per month, how much sooner would the car be paid off? And how much would this save her? So let's take a look at what we got. We got a loan of $18,000. We don't know what our monthly payment is going to be. The rate is going to be 8.4%. 5 years, done monthly. So R over M is going to be 0.084 over 12. MT is 12 times 5, so 60. And so we're going to have over here 18,000 equals R times 1 minus 1 plus I. And what is our I? 0.084 over 12. Let's see. 0.084 divided by 12 comes out even to 0.007. So 0.007 to the negative 60 over 0.007. And so we can slap that into the Wolfram and see what we end up with. So I is 0.007, N is going to be 60. So we got to divide 48,859. Gives us a monthly payment of 368.43. So the monthly payment, is this part A? Yep. Part A, the monthly payment is 368.43. Total payoff is the monthly payment 368.43 times 12 months in a year times 5 years. And so if I run that on my calculator, 368.43 times 12 times 5 is going to put us at 22,105.80. And so for the interest, we just need to subtract the 18,000 from that, which is going to be about 4,000 bucks. So interest is $4,105.80. Not a terrible deal for this person paying $4,000 over 5 years in interest. Let's see what's next for us, though. If she were to pay an additional $100 per month, so she gets this monthly payment and she's like, hey, 368 is really affordable. That's pretty great. I can afford even to put another $100 a month toward that. Let's see what impact that would have on the loan in terms of how much sooner she would have it paid off and how much interest she would save. So we are going to have our Surmton again. And we're going to get, she's still borrowing it for $18,000. The monthly payment, we're going to take 368 and add 100 bucks to it, so 468.43. The rate is going to stay the same, 0.084. Still 12 months in a year. We don't know how long it's going to take because this is going to shorten the loan. So R over M is still going to be 0.084 over 12, which is the same as 007. MT is going to be 12T. So let's swing it into our formula and see what we get. So S equals R times 1 minus 1 plus I to the negative n over I. And so we get 18,000 equals R. No, we know what R is this time. 468.43 times 1 minus 1 plus 0.007 to the negative 12t over 0.007. So what we're going to end up with, let's see, so 18,000, paying an additional $100 per month, so the new payment is 468.43. I is 0.007. N is going to be 12t because we don't know how long it's going to take in terms of years to get this done with the higher monthly payment. And what we end up with is 3.74 years. It's trying to run away from me. 3.74 years. So T equals 3.74. So how much sooner would the car be paid off? So the car would be paid off about 1 year and 3 months sooner, because 0.25 years is about what's missing off the end there, and 0.25 years is 3 months. So her loan would only last for 4 years and 9 months. So she would 3 years and 9 months. So she would be taking quite a bit of time off the loan. Let's talk about what the total payoff would be. So total payoff is the 468.43 times 12 months in a year times the new term 3.74. That's really scrunched over there. Pause this while I clean that up a bit. Okay, a little bit better. So I'm always running out of room on these problems. They're time consuming and such, but worth it, especially if I'm saving myself $100,000 plus on my house. 3.74. So the total payoff for this is $21,023.14. Interest paid is, what did you borrow? $18,000. So we subtract $18,000 from this. That's pretty easy to figure out. $3,023.14. So how much could this save her? Well, she would basically be just saving the amount that she pays in interest. So we're going to be comparing 3,023 to 4,000. So I'm just going to answer this over here on the left. This saves her about $1,000. So, apologies for running out of room all the time with these problems. They are lengthy, but hopefully they are useful. And I hope that you're learning something from this and you're able to make better financial decisions for yourself in the future as a result of this course. This is going to be the last problem that I do from the book, or what would have been from the book. I changed these problems around to make them much better. But from here forward, it's all practice problems for the Chapter 6 test. But what it really is practice talking about how to save money and retire wealthy and take loans and buy a house and save yourself a bunch of money in that process too. So I hope you enjoyed this so far, and I hope you enjoy the Chapter 6 review activities as well. Super applicable to our lives.